Okay, so do you guys remember last chapter when we were going nuts on binomials, right? Like all the yes, no kind of questions and P and Q and all of that stuff. Remember those? It was like N choose X times P to the whatever times Q to the whatever, right? But the problem is that sometimes it would have a question that was like a cumulative binomial or something like that, right? And what did you guys do if it was a cumulative one? Like if it was like, there's 10 problems and what are the chances you'd get at least 8 of them right? What would you do if it was at least 8? Yeah, you do the formula calculator, but you'd basically be adding up 8, 9, and 10, right? So you could like make a table if you wanted to and add up the probability of 8, 9, or 10, or you could do that cumulative function in your calculator that does like whatever 7 and below and subtract that from 1, and then you'd have 8, 9, and 10. But the problem with that is that we're using our calculator, right? And we have no really idea how our calculator works besides the fact that it must be doing that same binomial stuff that we're doing. But when binomials start getting big, as in like the ends start getting really big, then it becomes difficult to do those because you don't want to make a chart like example in this one. This one has an n of 50, where you've got 50 things in your chart and you're adding up all those things, right? And remember, if you're like, yeah, but then the calculator can do it for me. Well, somebody had to make the program in the calculator to figure that out. So
He's so passionate.
he is so passionate. Okay, David, you're adorable, but you're gonna have to go to the library for a little bit because you're getting too passionate and too loud. Okay. I know. Can you believe
Not
it?
even a warning today, just get out.
I'm starting to know when David is in a passionate mood that it's going to just going to be this way. I'll call you back soon, David. Don't worry. All right. Sorry to interrupt your conversation. So we're going to try using the normal stuff that we've been doing, that x minus mu over sigma, but this time we're going to be doing it with binomial problems, which I think is actually kind of fun, but I'm a weirdo, so don't take my word for it, please. Yeah. So the first question is, why are we allowed to use a normal distribution for a binomial problem? Well, like let's suppose that we had a situation where I don't know what P equals in this situation. Here, you can write it down. P equals 0.25 for this one is in the probability of success, which means that Q equals what? 0.75. All right, so let's imagine that there's let's think of something that has a 25% chance, okay? So let's say that you are taking a multiple choice test and there's 4 questions on it and one of them's right and you are guessing. You're totally guessing, right? You're totally unprepared. You're 100% guessing. There's a 25% chance you'll get it right, which means that if there are 4 total questions on the test, that most people, if they were just randomly guessing, would get 1 question right. But there are some people who would get 0 questions right. There are less people who would get 2 questions right. Almost nobody would get all 4 right if they were just randomly guessing, and so on. Everybody following me so far? Okay, but then if you increase the n to 10, now we got most people getting about 2 questions right. Some people getting 3 questions right, less and less and stuff. Can you see that it's starting to almost look like a bell curve here? And then when n goes to 25, now it's really starting to look like a bell curve. And by the way, this is centering around what would be 25% of however many questions it is. So if I put in my calculator 25 times 25%, I get 6.25, which means we should expect that you'd get about 6 questions right, which makes sense because the highest part of the graph right here is 6, you see? So it's kind of centering around that. As n goes to 50, look, it even looks more like a bell curve, right? And that makes sense because it's focusing around where most of the people would be getting it right, about 25% of the problems. And then some people are getting a little bit more right and some people are getting a little less right, but it kind of tails off on either side. But do you see how as n increases, a binomial looks more and more like a normal problem? Okay, so it's actually really convenient. We can start to use a normal to approximate a binomial, but we have to test 2 things to be able to do that. So the first thing we have to test is that n times p has to be, I think it's greater than, is it greater than or equal to, or just greater than? Yeah, just greater than or equal to 5. And also n times q has to be greater than or equal to 5. And the reason for that is that that's basically saying that if p or if q get really tiny, can you imagine that like this bell curve would shift, the center of it would shift really far to the left, and we really wouldn't have a bell curve anymore. We'd have like part of the bell curve because some of it would be cut off, or really far to the right, and part of the bell curve would be cut off. So it needs to be kind of somewhere in the middle for us to be able to use this and see the whole bell curve. So this is what we have to check. Okay. Megan's looking like she wants to die today. A little bit.
I was very close around the assignment last night.
Oh, did
So,
you really?
Yeah.
I'm guessing it was probably, was it parentheses issues when you got the
No,
ones
I
wrong?
don't think so, because I would type it in twice usually for most of the things. I just think, I don't know, like the first few things, I didn't know what to do, like how to set it up or anything. And like what thing to use for that. And then like the last stuff, I don't know how I did it, but what I got like, on like one of the last questions, I got a number so big that I couldn't even look it up on the chart, like it was
Oh.
4.8.
Oh, by the way, that happens sometimes. And when that happens, I mean, it didn't happen on this assignment, we'll fix that. But when that does happen to you, because it will. So don't think that if it goes off the chart or below the chart, like I did something wrong. That often happens on the AP test. But like if it's less than like that negative 3.5 on the chart, then you can assume that it's about 0% to the left, about. There's a small tiny percent there, but very little. And if it's past 3.5 on the upper end of the chart, you can assume that it's about 100% to the left, about. Again, it's more like 0.999999, whatever, you know, but pretty darn close. How about once we get through what we're going to do today, I'll just sit with you and we'll make sure that we understand what was going wrong.
Okay.
But don't be nervous about it because it was probably like the same thing over and over again, which got you. So we'll fix it. Don't worry. Okay. I don't know why I wrote David's name down here. So let's play for some prizes and cheer you up. Sound good?
Mhm.
All right. Megan and Tanner and Michaela and Mitchell and Caitlin and Krista. Hey, Michaela, have you signed up on that website yet for the test? Did we do that together?
No.
Okay, we need to do that today for sure. And then also, I need to know who still needs to bring in their money. Krista, did you bring in money yet?
No, but I can today when I come for basketball practice.
Okay, Michaela, how about you?
You already did.
Excellent, Mitchell?
I gotta check around here somewhere. I just gotta grab it and take it in.
Okay. If you guys can, make sure that's in by like Monday or Tuesday next week because we're running out of time. Okay, but Michaela's done. Michaela, you gave it to Miss Anderson, right?
Yeah.
Okay, good. All right, so let's see. Today is Friday, which is no, it's not Friday. It's Thursday, but it feels like a Friday. But it is Thursday, which is technically not Bug Day. It's Reptile Day and Amphibian Day, which I think might be the last one we have. Running so low, which is fine because we need a day for dinosaurs anyway. So that we have Dino Thursday, Dynamite Thursday. We need a better name for that. Anybody got one?
Is there another word for dinosaurs?
I keep wanting to say thesaurus, but that's just a thing you can look up. That's a thing you can look up synonyms in. So that's not at all a
What
dinosaur.
about like, oh, Titanic, I was gonna say like pterodactyl Tuesday and then switch,
Oh,
whatever, to Thursday.
interesting. Possible. Could also do pterodactyl Thursday. Okay. Looks like we have, oh, look at that little frog. Look at his little brown feet. Look how cute he is. Little brown feet, this little fat toad. I mean, great. You're great looking. Great. That's the way toad's supposed to look. And brown snake and last snake in the thing. And there's a gray salamander and one of these ones with the pink heads that are, what are those, like, horned lizards or something. Okay, so in a survey of adults in the United States, a certain number of people have said that they've seen a person using a mobile device walk in front of a moving vehicle without looking, or, you know, not get hit, but almost get hit. You randomly select 100 adults in the United States, ask them whether they've seen a person use a mobile device walk in front of them in a moving vehicle without looking. So we're looking for a percentage here. What percent do you guys think say that they have walked in front of a moving vehicle? Let's start in the middle of the list. How about Mitchell? And I just want to all remind you that Michaela plays rough.
8%.
8%. Michaela.
29%.
Oh, you see that? That's just her own decision. It's crazy. Tanner? 35. Megan?
13%.
13. Krista?
30.
30. Caitlin?
12.
Okay, no, we're all over the board. This is a good one. 34%, it turns out. Tanner, killing it here.
That's a lot.
That is a lot. That is a lot of people. Maybe they specifically asked people like in New York City or something. 34% said they have seen a person using a mobile device walk in front of a moving vehicle without looking. Okay, now, first of all, do you guys understand why this is binomial? Because if I ask somebody, have you seen a person using a mobile device walk in front of a car? They can say yes, or they can say no. Binomial, right? And I say I'm going to ask 100 people. So we know exactly how many I'm going to ask. It's a yes or no question. That's binomial. Do you see how annoying this would be to make a chart of 100 things and put it in your calculator 100 times, right? So the question is, can we use a normal distribution to do this? So all we have to check is this stuff. So we have to take 100 times 34%. And 100 times what's Q? 66%, yep. Shame on you, don't do it. What's 100 times 34%?
I have to second guess myself.
Oh, you can do it.
34.
34.
I have to do it.
Yeah, it just makes you feel better. Okay.
Yeah.
I will admit, especially when I was doing like important things, like if I was ever taking a test that like had some sort of importance, like the ACT or something like that, I did not trust myself at all. I'd be like, and 5 times 2 is 10. Yes, it is. Okay, I'm just making, no, I know it's 10. I'm just just in case. Let's make sure I'm not an idiot. So both of these are bigger than 5. So so yes, the answer is yes. You can use a binomial to approximate this, or normal to approximate this binomial. Now, Mitchell's going to ask the question, but what if the answer is no? Right, Mitchell? Yes, I'm going to assume that this is a yes, that he is, because he's paying attention. All right, so the question is, what if you can't? If the answer is no, then you have to use like the binomial formula, like we used to. So I'm going to write here, if no, use the binomial formula that we did before. Now, this seems like this is a pretty easy thing, but it's actually like a little bit tough. because you've got to figure out how to use a correction for continuity, which is difficult to understand. So we're going to draw a picture to help you understand it. See if I can help. So we're going to take this nice and slow, which is why we're breaking this into 2 days. All right. So we are going to draw a picture of this between 270 and 310 successes. But instead of drawing like a normal binomial curve, I want you to draw something that looks like this, okay? I want you to draw like you've got a whole bunch of these bars and they're going up like that and they start going down. Make it about symmetric. Does not need to look perfect or anything like that. Because a binomial is not really continuous. It's not really like a curve. It's like what we had on the previous page, where as n gets bigger and bigger and bigger, it starts to look like a curve, but you see those jagged edges? Like it is still definitely just a bar graph that we're saying looks kind of like a curve. So let me see if I can explain this well. And this is really one of those days, guys, where if you don't understand this, you need to speak up because I'm nervous. I'm not going to do this justice. Let's say that this bar right here is 270, this whole bar, okay? This bar represents anybody getting 270 whatevers. And this bar over here is 310. But do you see how if I was to capture 270, I'd be actually going in the middle of that bar, not grabbing the whole bar. And if I was to grab 310, I'd be going in the middle of that bar, not grabbing that whole bar. But I want, do you know what the word inclusive means? Inclusive means including those things. So we want between 270 and 310 successes, but including 270 and including 310, okay? So we want to include this whole bar, and we want to include this whole bar. Do you remember when we were doing, when we were graphing stuff and we would have to do that plus or minus 0.5 to get to the edge of that bar, right? Because the middle of it was that number. And so we'd have to be like, well, technically, if I wanted to say where this bar, the edge of it is, it's more like 5.5, right? Not 5, because then I wouldn't have a choice. So this edge is actually 269.5 because it's a little below that 270 mark. What would this edge be?
310.5.
Exactly. That's what a correction for continuity is. It is, it's adding or subtracting 0.5. So you can include the whole bar. And this is only on binomials. Do you do this? Well, binomials that are basically turned into a normal. So binomial turned into a normal problem. But like all that central limit theorem stuff before, all those regular problems before, that's not the case. Okay, so it's between this and this. So the final answer for this problem would just be use a correction for continuity. So basically, all you're saying is that you would be looking for these numbers instead. So instead of 270 to 310, we just changed the edges essentially to include the whole bar. All right, now we're gonna try this again. If I was drawing this well, all of these bars would be approximately the same width, but I'm going to call this bar 158. All right, this time we need at least 158. All right, so think about the words at least 158. Does that include 158 or not?
Yeah.
Yes, that includes 158. Okay. So since that includes 158, is that 158 and higher or 158 and lower?
158 and higher.
Right, we need at least 158, like 159 would do, 160 would do, but at least, okay. So I'm going to draw an arrow here. I want from here over. Okay, so X has to be bigger than what now? It can't be 158. What's actually this? What's this line right here? 158 is in the middle of the column, right?
So 157.5.
Exactly, 157.5. So you have to kind of pay attention in this to figure out whether it's going to be a little less than 158 or a little bit more than 158 based on whether that bar is included. Yep.
Are you ever gonna have like a situation where it's not, I put in the bars and like one for me?
No, it's always going to be 0.5 for sure. The question just is going to be for you, do I include the bar that we're talking about or do I not? Okay, so like, and here's an example where you don't include it. So let's try this one. How am I doing on this? Are you guys feeling like you're kind of understanding what I'm talking about here?
Mhm.
I'm just talking to the people in front of me. People online, how you doing? Thumbs up, thumbs down, a little shaky. Okay. Mitchell, no opinion? You doing okay? Or have you not made a decision yet about how you're doing?
We'll see after this one.
Okay, we'll see. All right, so we have another bell curve here. Just pick one of them to be 63. And the reason why we're just picking one randomly right now is because I haven't told you like a mean for any of these, right? You don't know where it would be in relation to the center. We're just practicing to figure out how we would be able to do this when it was a regular problem. All right, less than 63. Remember, this bar is like 62. This bar is like 61, etc. So where's less than 63? Should I go on the left side or the right side of this bar? Left. And then we're going this way, right?
62.5.
Yes, because I don't want to include this time. I don't want to include 63. I want it to be less than that. So I'd say X has to be less than 62.5. All right. So now what I'm going to do is I'm going to show you how to do this using a normal distribution to approximate a binomial. All right. And we're going to start doing this a lot. I don't think I've done this technique with you before, have I? Where I have two columns like this? Okay, we're going to start doing this a lot because I think that it will really help you. On one side, I'm going to write directions, like exactly how to directions that you can follow. And on this side, I'm going to remember like tips, like, hey, remember this, don't forget that, this is important, that kind of thing. And then down here on example 3, we're going to do an example at the exact same time. Okay, and I'm going to label it as we go. So we're going to take these notes very carefully and very slowly to make sure that everybody feels comfortable. All right, so let's start with The first thing you need to do is to verify that the problem is binomial. Do you guys remember what we have to do to figure out something's binomial? Yeah. So is there, we need to know if there's like a P, right? A probability of success. What else do we need? A Q, probability of failure. It has to be a yes, no question. You need an N, because you need to know how many trials there are. So that's about it. You just need to check those things. So while we're doing this, let's go down to the bottom here. Ooh, we got another one of these. Good. Number of people, percent of people in the United States admit that they snoop in other people's medicine cabinets. All right, the important thing is admit. So in like, as if you go to like a friend's house or you go to somebody else's house and you're using their bathroom, would you open up like the bathroom mirror and take a look in there? Would you open up under the sink and take a look under there? Well, you might not. Maybe you're a good person, but do you think everyone's a good person
No,
is the
she
question?
does. Tanner does. She just won't admit it.
She does, huh?
No, I don't.
Yeah. Tanner doesn't, guys. She swears she doesn't. Okay, I'm gonna let Tanner pick last, and we're going to, no, Tanner, you get to pick first because last is the best spot to be, right? All right.
Because I don't think a lot of people do that.
Well, then just say
Oh,
something
good.
really low.
Wait, I'm saying a percent, right?
Right, a percent.
23.
23%. Hold on. I'm just making sure really quick. I know, isn't that weird? Oh, they switched it on me. They have a different one now. I wrote this originally when it was a different version of this textbook. But I can look it up really fast. Mean spouses, hidden purchases. Yeah, there's a lot of creepy stats in this chapter, actually. Well, I'm just going to Google it. Nobody else Google it. All right, so percent of Americans that admit
Well, you gotta stop them taking.
yeah, what, I mean, don't you want to know, like, if they have heartburn?
See if they like have like extreme bipolarism.
Okay, so here we go.
I'm just kidding.
Tanner said 23%. Well, then let's this way. Michaela.
Like 32.
32.
It's a
Mitchell.
big number too.
27.
27. Caitlin. Going big, you going low?
20.
20. Krista, do you have faith in humanity?
33.
Oh, she does not. Megan?
I'll do 41.
41%. And according to Google, it is 40% of Americans think that it is okay to snoop through somebody else's.
And they talk about it.
Yes. Yes, this is a
That's rude.
survey into, well, you tell them,
That's
Tanner.
messed up. That people would admit it.
40% of house guests admit to snooping in medicine cabinet, according to a survey. They collected responses, get this, in Texas. Okay, in Texas.
Yeah.
However, they collected responses from 605 men and women between the ages of 25 and 54. And yeah, about 40% said that, yeah, I'll snoop in a medicine cabinet. Okay, so step one. We had to figure out, do we have a P, do we have a Q, is it a yes, no problem, do we have an N, right? Okay, so what's our P, what's our Q, what's our N, is it a yes, no? 40, so 0.4, Q, 0.6, N. 200 is how many people were asking. Is this a yes or a no question? Yes, it is. By the way, if the answer is no, then at that point you have to just say, I'm not going to do this at all. We're going to do a binomial problem. If that happens, by the way, it will be a reasonable problem. So if you're in your homework and you're like, the answer was no, and I have to add up 85 numbers. No, you don't. Okay. It'll probably be like the answer was no, and you have to add up 2 numbers. So chill out. Like they're not going to be completely evil, although I do enjoy when the book is evil. Don't get me wrong. Like that's great joy for me. Oh, by the way, Tanner, you never got a prize. When you first won, would you like an animal, a bouncy ball, or an M1 sign? M1 sign? Animal. Snake. Toad. Don't take the one Megan wants. Megan, don't say it. You know Megan's got one in mind, right?
Don't take mine.
Yeah.
Don't take what I want.
I was gonna take the green frog.
Is that the one you wanted? Oh,
Okay.
thank goodness. Which one do you want, Megan?
No, space.
Yes, snake. Snake.
That toad is a spring peeper toad.
That's right. You got that one before.
Yeah.
Did you, have I ever told you that my husband likes to tease my children with the snake thing? Have I ever told you that? That's so cute. He'll sit next to him on the couch, like they'll be like shoulder to shoulder on the couch, right? Sitting next to them. And and Mitchell, by the way, your homework is like almost nothing tonight, so don't be mad that I'm telling a story, okay? So they're like shoulder to shoulder, and he'll sit next to them like this, and then he'll go snake, and they'll be like, no, and then he does this with his hand, that, right? And all he does is he like runs his hand down their arm where he'll be like, snake, and they'll be like, ah, like they lose their minds. He doesn't tickle them. He doesn't do anything beside go snake, and then just moves his arm like this. And like, he'll maybe go like by their forehead or something like that. Like he doesn't do any kind of tickling whatsoever, but they both, like if he sits next to them and goes, they like just the beginning of a hiss, they both are almost peeing their pants laughing already. Like they're losing their minds. It's super cute. So I enjoy that. But yeah, so every time somebody says snake in my head, I imagine Bo going, snake. Whatever. Sorry. Okay, so the next thing that you have to do is you have to decide whether you can use a normal distribution. Okay. So when you're deciding whether you can use a normal distribution, what that is it's checking that NP is greater than or equal to 5 and NQ is greater than or equal to 5. And if you can't do it, then you just use a binomial. So if I'm just going to write can't, use a binomial. Also, by the way, you don't really have to check both of them. And you don't even have to fully figure out the answer. For example, let me show you. For number 2 down here, I'm going to write, I've got what, n times p, right? And that would be 200 times p is 40%. All right, guys, 40% of 200. You don't have to put it in your calculator. Wait, stop. That is actually, yes. Good job. Well, great job. But suppose we didn't know that. Okay, suppose we haven't figured that out. Can you tell me, is 40% of 200 bigger than 5?
Yeah.
Yes. Okay. Yes.
I think of it like that. I wouldn't be like 40% of 200. I'd just be like 0.4 times 200, like automatically. Just auto.
Right, and you can. I'm just saying that like you don't even have to know the answer. You just have to know, is it bigger than 5? Do you see what I mean? And now, do you understand why we don't even need to check NQ? Because that's 200 times 60%, which is you know, also bigger than 5, right? But they both have to be bigger than 5. And so if it's a close call, use your calculator. But if you know, like this is not even close, like this is definitely bigger than 5, there's no even reason to do it. Sweet. There you go. We're almost done. Okay. Going back up to the top, step 3. Find the mean and standard deviation. Okay. Let's see. I'm going to give a prize to somebody here, and this is going to be a speed prize. So we're going to just give it to the first person who does it. Okay, ready? I'm going to look at all of you. I'm looking at everybody online. The question is, does anybody actually remember the formula for standard deviation or a mean from binomials? Just unmute if you remember it. It was in the last chapter. It was like a special formula that we had on a different page. It had N, P's, and Q's in it.
Oh.
Yes, mu is N times P. Which one? What is this? So close. N times P
Oh,
times.
square root it.
Yes, much better. All right, I'm gonna give it to both of you because you helped each other. Do you want more animals? Kind of. Depends on which animal. I am running, okay, these are all just repeats in here. So the only ones that are all different are these.
Go ahead.
You want I one more time?
Can I have a bounce?
I would like a bouncy ball as well.
Oh,
Yeah.
okay. I've got a ladybug pink and a swirl orange.
You can go first.
Do you solemnly swear, put your hand on your heart, say, I solemnly swear that I'm not going to bounce this in anybody's classroom
And I will not bounce this in anyone's classroom.
With-
Correct.
without their permission.
Without their permission.
And if Clark doesn't give you permission, then you're not going to bounce it in there.
If Clark doesn't give me permission, I won't bounce it.
Okay, also don't bounce it in the hallways.
Chances are I'm probably not gonna bounce it at all.
Hand over your heart.
I'm going home after this.
Okay, that's a good point. Okay, so I guess you can choose to bounce it in your own
Will you
house.
bounce it in her classroom without asking?
Yeah.
Right after you don't say the oath, you bounce it in her classroom.
Oh, you guys missed it. Okay, so what happened just there was that I tossed it at Tanner. Tanner missed it. It wasn't a very good toss. And then it bounced, and then Megan yelled at Tanner for it, which was very funny. All right, so going back up to the top. Yeah?
So for part 2 on the remember side, so you just put can't use, so that's if it's not greater than 5, you can't.
Right, so if you can't, so if maybe this would be
Not greater than
right?
5 or
Yes, if not greater than or equal to 5. Okay, better?
Yeah.
Thanks. Okay, going back down, step 3. All right, so this time, n times p, we're going to take n times p to get mu. Megan already told us what that was. 200 times 0.4 is
80.
80 is the mu. Nice job. And then for the standard deviation, we need the square root of NPQ. Yes, please use your calculator.
Yeah,
6.92, you said?
2820.
Anybody confirm that? I have not. Anybody online confirm that the square root of 200 times 0.4 times 0.6 is 6.92 about?
Yeah.
Okay. All right. So now we've got a mu and a standard deviation. And now we're gonna go back up. What do you think of this format? Do you like this where it's like directions, remember, and then an example at the exact same time? Okay, and that's why we're taking this nice and slow. Number 4 is find the appropriate correction for continuity. which is what we just practiced a little bit ago. That plus or minus 0.5. And over here on the remember side, I'm going to write draw a picture. And that you're going to add or subtract 0.0 or 0.5, not 0.05, 0.5. 0.5. All right, let's go down here to the bottom. I'm going to draw myself a quick little picture. Okay, it looks like in this problem it says, what is the probability that at least 70 will say yes? Now in the middle was what, 80, because that was our mu. So let's say that 70 is like this one over here. It's a little bit to the left. But we need at least 70. So should we include 70 or not include 70?
Include it.
Include it. All right, here's my little bar. I'm going to include it. I want to go this way. We're including 70. So I'm going to write here, we're going to say that x has to be greater than 69.5. We're not going to use 70. We're going to use 69.5. Okay. Can I move on? I don't know how fast I'm going. People online, I'm looking at you. Give me a thumbs up if you're ready to keep going. Caitlin, let me know when you're ready. Okay. Caitlin, you good? Okay. All right. Now, the next thing you're going to do is find the z-score. Z equals x minus mu over sigma. Okay, so remember we've got a specific mu and a sigma. So down here, I'm going to write, thank you, Caitlin, or whoa, you're not Caitlin, Tanner, not even close. X minus mu over sigma. So my x this time is 69.5. Hey, David. Did you get all the answers right? Cool. All right, so 69.5 minus 70 over sigma, which, no, not 70, minus 80, right? 80 was our mean. And our standard deviation was 6.92. So where did the 70 go, guys? Because 70 is in the problem, so where did that go? Thank you. Anybody remember? It says at least 70 will say yes. Why is there no 70 in here at all? Anybody want to tell me, where did this 70 go? Because it says we need at least 70, but here in this problem over here, I didn't write 70 once. What?
You didn't write 70 in the entire thing.
Why don't I need it in the problem? Right, because I changed 70.
Honestly,
Yes,
there was like, I feel like this is really easy.
it is. Yes, yes. Don't be embarrassed. So I changed 70 to 69.5, and now I'm using that instead. Okay. Okay. All right. So in my calculator, I'm doing 69.5 minus 80, and then I'm dividing by 6.92, which I got negative 1.52. You guys get the same thing? Okay. All right. We're almost done. Now you need to, for step 6, look it up. Yep. On the z-score table. I'm going to write over here, this is on page A16, A17. I'm also going to write pay attention to that picture. So we want all of this stuff. So we want to the right of negative 1.52. So if you look up negative 1.52, what do you get?
You get 0.0643.
0.0643. Can somebody confirm for me, please?
Then you have to do 1 minus.
Yes, but I don't know if that's right yet because nobody's confirmed. Mitchell confirmed. All right, so we're gonna do 1 minus that. Because we want to go to the right. And what do you get?
9357.
There we go. And that's how you do a binomial approximated by a normal continuity problem. Feels very complex, doesn't it? Okay, so here's what your homework is. Are you ready for this? Your homework is the last 2 problems in the examples. That's all, okay? I just want you to try example 4 and example 5 and come to me on Monday, and we're going to talk about them and make sure that you guys fully understand this before we jump into the homework, the actual homework. Because you will get more practice with this, but today, just tonight, just for this weekend, because also I'd like to not give you a lot of homework for the weekend. By the way, David, you can let Emily know that you guys are done for the week. I'm trying to give you guys a break since it is actually spring break, okay? So you only have to do 2 problems, and you just have to do these 2. But first, we should probably win some prizes by making some guesses, right? Hey, David, do you want to be involved in this guess game?